Hello everyone. Today we are going to discuss binary search, and this is a search algorithm which will help you to search a particular element in the given array faster. And if you see, the complexity of this particular algorithm is big O of log n. Okay. Now let me explain you how this code works and what all things you need to pay attention to whenever you are writing a program. You can observe this particular function. This is the binary search function. If you look at this carefully, this is the start of the program, and we have got two functions. One is binary search and another is main function. You all know that a C program starts its execution from the main function. We'll go to the main function first. In the main function, you can see we have got a predefined array, and this particular array is having 3, 4, 5, 6, 7 elements. This is having 7 elements. See, it is easy for us to count, but we cannot find the length of an array. We do not have an inbuilt function, and that's why what we will do, we'll try to find the length of array here. But before explaining all these things, you need to understand how the binary search is done. Okay, let me take an example array. We'll take a array 2 and we'll be having 7, 10, 3, 4, 8, 15, 9. Okay, this is our array. But if you look at this, there is a issue. You cannot find an element from this using binary search. The reason behind this is not sorted. You can apply binary search only on sorted arrays. That's why I'll be rearranging this array in sorted order. We have got 3, 4, 7, 8, and then 9, 10, and 15. Now if you look at this is sorted in increasing order. Now if you want to find an element in a sorted array, the simplest way to implement this is using binary search. How do you identify a binary search? How do you identify an element using binary search is, you will have a key first. Key is an element that is to be searched in the array. Okay, let's imagine that our key is 9. Fine. Now what you do, we'll go, we'll try to find what is the first element, that is 3, and what is the last element, 15. But here you need to identify what is the length of this particular array. For that, we can count 1, 2, 3, 4, 5, 6, 7. There are 7 elements. There are 7 elements, and therefore if you want to find the middle element, how do you find? In the binary search, every time you'll be finding the middle element and try to compare with the key. So if you want to find middle of this 7, what you do? This is 0th element, right? And this is the 6th element, and already you have found the length of the array, and that is L, right? So L is equal to 7 here. Now if you want to find the middle element, what you will do? You will actually go for length of the array divided by 7. Okay, divided by 2, not 7, 2. Okay, so 7 divided by 2, you get 3.5, right? If you are getting 3.5, this is 0th, first, second, third. So this is the third element. What you do is you are going to compare 7 and 8. You are going to compare 7 and 8. If the key which is to be searched is greater than the element that you have compared, then you will be changing the value of, initially we have s is equal to 0. This is our starting element, start element. L is equal to 6. This is the last element. This was our original array. In our original array, we have got s is equal to 0, that is starting element, L is equal to 6, that is ending element. Now when I searched 9 and when I compared 9 with 8, I found out that 9 might be in this particular half of the array. Alright. So what we will do, we'll change the value of yes to 3, right? We'll change the value of yes to 3. See, if you change the value of s to 3, again what will be the problem? We will be starting from this element, but already we know that 8 is not equal to 9. That's why we will leave this element. We'll make plus 1, and so we'll make s is equal to 4. S is equal to 4 means this element, and then s is equal to 6. L is equal to 6. This half. S is equal to 4 and L is equal to 6. Now we will do the same work. We'll just compare key with key is equal to 9. This 9 will be compared with the middle element. To find out the middle element of these both, what we will do? 6 plus 4 divided by 2, that is equal to 10. So 10 divided by 2 is equal to 5. 0, 1, 2, 3, 4, 5. This is the middle element now in this array. In this array, this is middle element. Now what you do, you will compare array 2 of 5 with 9. Fine. Now array 2 of 5 is what? It is equal to 10. You can see this 10 is 0, 1, 2, 3, 4, 5. Therefore array 2 of 5 is equal to 10 is equal to 9. It is false. But you need to identify now which part of the array you are going to take. Now we have got this 10 is greater than 9. So it is obvious that 9 will not come here after 10. So 9 will come here only. Okay. In this case, you will be having L is equal to. Now we compared with this particular element. Now we have got S is equal to 4 as it is. You will keep S is equal to 4 as it is. You will be changing the value of L. L is equal to mid. What is our mid value? Our mid value is 5, right? You will make it 1 less than the mid value. That is 5 minus 1. 5 minus 1. This is equal to 4. Now after testing this one, our mid value, our last element will be equal to mid minus 1, and that will be equal to 4. And now you can see S is equal to L. Now if you calculate mid is equal to S plus L divided by 2, this is L. So S plus L how much? 8 divided by 2 is equal to 4. Now we have got mid is equal to 4. You will every time calculate mid using this one. Now you just look at this. We'll compare key is equal to 9 with array 2 of mid element, right? What is the value of mid? Mid is equal to 4. So if you write 4 here, then our value is 9. So 9 will be equal to 9. That's why it will return 4. This will return 4 because array 2 4 is equal to 9. You can see the same thing is written here in this program. We have got 1, 5, 8, 9, 11, 18 and 20, right? There are 7 elements here also, and if you want to find the length of the array, it is not, we do not have any inbuilt function, and that's why what we do, we'll try to calculate size of this whole array. You can see size of array. Size of array will be, you see, we have declared each and every element in the array as int. That's why it will be 4 into 7, 28 bytes. This will return 28 bytes. And size of first element, what is size of first element? This is our first element divided by 4 bytes. So bytes cancel, 4 on the 4 7 the. Therefore we are getting L is equal to 7. We have got L is equal to 7, and then S is equal to 0 means we are going to consider starting element S is equal to 0 and L is equal to 7. We have got the value. Now what we do is we need a key to search, right? So we'll go for key is equal to 20. Now result, This is a integer which will have the value of returning value of this particular function. Now this function is actually defined in our program. You can see here binary search. You can observe this is a binary search and the returning data type of this function is integer type, and the name of the function is binary search, and this is going to take 4 parameters. You need to remember these are all variables array. First one will be array, second one is k, third one is s, and the last one is l. There are 4 variables and we have mentioned the data type of each of the variable. Whenever you are calling this function, you must make sure that you will be passing these 4 values. So if you look at this one, you can clearly see binary search. This array is a array, this array. Okay, so first one we are passing as array. Second one is key. You can see what is the data type of this key. It is int. You can see yes, yes is also int, and l minus 1. We are sending l minus 1. It is because what is the index of the last element? 0, 1, 2, 3, 4, 5, 6. 6, right? But what is the value of l? L is equal to 7, right? So we are passing l minus 1. It is not 1 minus 1, it is l minus 1. Okay, fine. Now as soon as you call this function, the control of your program will go to this place here. Binary search, here we get an array. Whatever the array we have declared here, we'll get it here. Just clean it. Now you can clearly see that this is an array, this is an integer, this is integer, this is integer. Already we have passed. At present, what is the value? This array is equal to 1, 5, 8, 9, 11, 18 and 20. And what is the value of this k? 20. And what is the value of this s? 0. And what is the value of this l? 6. We have called it in this way. Now if you look at this one, in first stage, we are going to test s is greater than l. This happens when you change the value of s and l here. See, these functions are actually changing value of s and l. At that time, this may happen. In that case, it will be returning minus 1. Fine. Returning minus 1 means value not found. Value not found in the array. If it return minus 1, it means value not found. But we come here, we'll be calculating the mid element. For calculating mid element, already I have told you mid is equal to s starting element plus last element l divided by 2. This is 0 plus 6 divided by 2. This will be equal to 3. So 0, 1, 2, 3. It will be searching third element. It will come here. Array of 3. Array 3 is equal to 9. Is it true? No, it is false. It will come here. Else if you see 9 is no. What is value of k? It is 12. 12 is less than 9. This is also false. So it will come to this part. Here it will again call the same function. This binary search function will be called once again. Array value will be same as it is that we have passed. This k value will be as it is 20. Mid plus 1. What is the mid value here? Mid value we have got as 3, and so it will be 3 plus 1 now, and the l value will be same as we have passed. It is 6. It will be 6. So in the second iteration, the values that we are getting here, we'll just modify this one. The values that we are getting, this is same, but s is equal to 4 and this int is equal to int l is equal to 6. These are the things that we got now. Now we'll just clean it and we'll go for the second iteration, second recursion. We'll call it as recursion call. If the function is calling itself again and again, that is called recursion call. Fine. Now you can see s is greater than l, false, so it will not come here. Now you can check mid value, s plus l, 4 plus 6, 4 plus 6 divided by 2. This will be equal to 5, right? 10 divided by 2. Now array of 5 is equal to k. k is equal to 20 here. Now we'll be testing array of 5, 0, 1, 2, 3, 4, 5. We'll be testing 18. 18 is equal to 20. False. So it will come to else if. It will check key is equal to 20. This key is equal to 20. This array mid is 18. Is it true? This is also false. So it will again come here. Here return binary value. This is same as it is. We have not changed the value of array. K value is not changed. If you come to this part, you can clearly see mid value has changed. What is the mid value now? It is mid value is 5. So it will become 5 plus 1, and the L value is not changed. It is 6. Right? So mid value and L both are actually 6 now. That's why we'll call this function again. I have already told you this is recursion call. We'll be calling the same function again, binary search. Binary search. This is also taking again 4 values, 4 parameters. Now you can see there is a modification in the numbers. Again, we'll come here. You can see clearly this is same as it is. This is same as it is. Now S has become what? 6. This has become what? 6. Alright. Now you can check here. 6 is greater than 6. Is it true? No, this is not true. This is false. So it will not enter into this. So you come here. It will calculate mid. Mid is equal to 6 plus 6 divided by 2. Fine. This is equal to 6 again. Now if you see, if ARR 6 is equal to 20. What is ARR 6? 0, 1, 2, 3, 4, 5, 6, 20. 20 is equal to 20. Right? You can clearly see this mid value will be returned. If this is the case, mid value will be returned. What is the mid value at present? It is 6. So it will return 6. Now if you come here, now value of this particular function call will be equal to 6. Therefore result value also becomes 6. Fine. This is assignment. And after assigning, you can clearly see the element found at this result, that is 6. Fine. We'll execute this once. You can see I have got a function here, binary search, and this is taking 4. As I have mentioned, I have explained the same thing in the video. Now if you go for execution, let me increase the size. Okay, fine. Now you see when you are executing gcc binary search.c, if you want you can give the output file name out out. Fine. Now dot slash out out. You can see I have got element found at 6. Now in case if you change the key value, if I make it 9, and if I go and execute, you can see element found at 3. Fine. You can see 0, 1, 2, 3 element found at 3. Now in case if I write something other than these elements like 19, come here, execute, you can see element found at -1. Since it is returning -1, what you need to do, you need to write a condition here which says if result is equal to -1, then we'll take this part, right, and element not found will show element not found, element not found, and just remove this part. In the else part, we'll write element found at result. Okay, this should work fine. You can see element not found. Now if you change the value to 9, you can see clearly element found at 3. Fine. That's all. Thank you.